Good morning everyone, and welcome back to our channel. Let's continue with our comprehensive and detailed course on CNC lathe programming. Today's topic is subprogrammes. Subprogrammes are a fascinating and intriguing part of CNC programming, especially if you start using them and if you follow me along with parametric programming. Maybe later I'll give you a brief overview. First of all, what does subprogram essentially mean? Let's think about a program, or the main program, the one we typically and usually write, that has its own beginning and end. When writing the subprogram, we will insert some codes, definitely, including a name and a final M30 code. Keep in mind that I'm kind of starting over because I'm using a simulator that's mainly FANUC, especially for the macros. But what I'm trying to do is give you a general overview that applies to all machines. You can find subprograms in all lathes. As I write lines of code, at some point I might find myself wanting to write lines of code that I can either repeat during my program or vary without changing the main program. That's why I write myself a new program, compile some code, and make sure I can call it back. For this, CNCs usually require some small differences in how subprograms are written. Some, but not all, ask for a specific name. FANUC, for example, requires an O followed by 4 digits, at least. The older FANUCs, the current ones, probably the very latest, can also be called Pipo, Tizio, Caglio, or Sempronio. What really matters especially is to differentiate them at the end phase. So, M99. I've found other machines that end programs with RET and others. M7. It doesn't matter at this point how the subprogram ends, but it does matter that the last block of a subprogram is an M or some other special character that says that the code lines are part of a subprogram and that you will have to return to the main program. So, when we call M98 to subprogram error 100 within a program, the machine reads the main program, sees this line, then moves into the directory, reads, since it doesn't encounter an M30, but an M99, it returns to the next line after M98 and continues reading the program. Also, this subprogram can be called multiple times within the main program. Additionally, we can call 1,000 subprograms as needed. In fact, a main program can be made up entirely of subprograms. Why use this? Reasons include it can be used to repeat a groove multiple times with slight advancement. It can also help manage a family of parts. For example, we might have parts that are all the same in diameter and length, but the section changes. I'll perform the chamfering and external turning in the main program, then create a series of subprograms to handle this hollowing out, done differently each time. With the drawing, I'll call programs 0100, 0200, 0300 within the subprogram. For example, imagine we have a bar and we need to make a 4mm groove. What is the use of this type of programming? There can be many reasons. For example, it can be used to repeat a groove multiple times in a repetitive manner while advancing slightly on the piece. It can also help efficiently and effectively manage a family of parts. For instance, we might have parts that are all the same in diameter and length, but the section changes So I'll do the chamfering and external turning in the main program, and then I'll create a series of subprograms to handle this hollowing out, which might be done one way this time, in various ways another way next time, and so on. So when I have the drawing in hand, I'll call upon programs 0100, 0200, 0300 within the subprogram. Let's take an example that we'll later see in the simulator. Imagine we have a bar and we need to make a 4mm groove. Using a tool with approximately a 4mm cutter, the bar has a diameter of 100 units and the groove at the bottom measures 90 units. These measurements are important to ensure the components fit and function correctly. In this example, I am creating a subprogram for a CNC machine. It starts with a percentage sign and 00100, the program number. I call the turret with T0101 and use M4 to start the spindle. G96 sets the speed to S100. The machine moves to position with G0Z10 X102. Then G1 moves the tool to X90 at F0.1. After cutting, the tool retracts with G0 X102. The subprogram ends with M99, returning control to the main program. This sequence ensures precision and efficiency in machining. So I basically call or create a main program, and here I essentially have no issues with the name. I can indeed call it whatever I actually want. I include all the preparatory functions I'll need, like G92, S2000, G95, M42, and that's everything I'll need later. That's why I'm just writing M98P0100, which is a command used in CNC programming to call a subprogram. This command helps in organizing and managing complex machining operations by allowing the main program to execute a separate set of instructions. It makes little sense to do something like that as one program sufficed. It makes sense when I need to repeat this groove multiple times in the negative Z direction. For example, when I have to create a series of grooves spaced 10 mm apart. So I use a function called G52 Z10 M98 P0. London. Approximately 0100 or so perhaps. G52Z10 is the translation of the origin. In simple terms, this origin is taken and moved 10 meters for the machine. The origin is no longer here, but is now 10 in the negative Z direction. So the program is repeated, shifted by 10 millimeters, which means it will no longer be Z10, but Z20, physically for the machine. I then want to do another G52. Z minus go is no longer 10 millimeter, but 20. So Z minus go 30. M98 or 100, and here it gets convenient. The more attentive ones, among those following this course, I see there are also capable people who are probably taking the course out of curiosity. I thank them because they often point out small inaccuracies. If I had them in front of me, we could probably see it together, do it in front of a video. If I get distracted, it might not get highlighted. The more attentive ones might say, wow, but there are other ways. There are conditional jumps. The luckier ones might have G10, which is an optional parameter that allows, at least on some machines, to repeat the cycle multiple times. I can create unconditional choices with parameters or calculations. All this stuff in 3 lines. Yes, it's true. This is one way, a simple way, an easy way to repeat a subprogram as I need it, and I use it a lot. It's not the only way, just so you know. It's one of many other things. Remember this. And I'm just planting a seed in your mind because I'll make a suitable video about it. We're used to seeing X and Z as numbers. In reality, Z are values. So when we write a subprogram, we could also write that Z minus 10 is equal, actually. Let's leave Z minus 10 equal. That X102 is, do you see, A, and mix 90, that is the groove bottom, is B. Before calling the subprogram, we could set A, and mix 90, that is the groove bottom, is B. Before calling the subprogram, we could set A equal 102B equal 90, equal 102B equal 90. When we call the second subprogram, we could tell it that now B is 80. When we call the third subprogram, we could tell it that now B is 70. So we'll have a groove like this, a groove like this, and a groove like this. The subprogram becomes very important when used together with variables or unconditional jumps. Oh, now I can't remember in time about logical operators. I mean, remember that it's true that X can be equal to A, but it can also be equal to A plus C. Just a tiny aside that I wanted to introduce before moving on to the simulator. So, the subprogram, but also the main program, can use X equal to letters, meaning parameters. The subprogram, combined with parametric programming that we'll tackle in detail, opens up a world of possibilities for the programmer. So the machine becomes as smart in executing the program as the person programming it. You can even make the machine make decisions like, if value A is greater than B, do 3 cycles. If A is less than B, do 2 cycles. That's really interesting. Now let's move on to the simulator. Here we are on our simulator. I've entered 2 programs. One is the main one called multiple goal, and the other is 0100, which is a commented subprogram. Let's open 00100, use TOR 505, move to X102 Z10.5, groove to 90.5 deep. Then I position myself at X102 Z10.5 and insert a groove macro that creates a deep groove down to 90.5 and wide down to Z15.5 with a tool break and a shift of 1.8 mm. Do you remember G75? If not, check out the video. It explains it really well. Once I've made the groove, I move to Z7 and execute a profile with an external bevel, a bottom radius, and a finish up to halfway down the bottom. I raise myself from Z to Z+, and I do the same thing. You see that I finish with my 99. I'm going back to the main program, multiple grooves, and I'll run it for you. So I call up a rough piece with a diameter of 100 and a length of 100, G52 S2000, so limiting the RPM, M42, G95, and I call the subprogram 0100. Let's run it, start, and here we have made a groove. Let's take a look at it, rotated in 2 dimensions, so Z and X, and let's check out the path. The right tool for this task is finally here, and it is exactly what we need to get the job done efficiently and effectively. So we begin with a single step, ensuring everything is set up correctly from the start. Here I proceed to run my macro, which automates the process.
and saves us a lot of time. Following that, I carefully profile my groove, making sure every detail is perfect and up to our standards. Are we all set and ready to move forward with confidence? Edit mode, replicate board steps. At G52, set Z to 15, insert M98P0100, simulate. Always say, time to manipulate. Copy. Z. Minus we make 15 EOB insert, M98P0. 100 insert and simulate. Perfect, I'd say. I won't say this anymore. From now on, I'll say it forever. If one day you see me on the street, you can absolutely tease me because I keep saying, at this point, it's definitely time to manipulate the program. So we go back to edit, we come here, press the pair button, highlight 2 lines, copy, and paste. Z15 becomes Z30, and this becomes Z45. Let's simulate, and I haven't restarted the program. You see that I'm making 4 grooves, even though I only programmed 1. I'd say that was the point of the subprogram. I wanted to convey with this first video. As I mentioned earlier, now we'll see something more interesting, namely parametric programming. So I look forward to seeing you curious in the next video. Thank you for being with me. The only favor I always ask is, if you like the video, please share it on your social media to help spread the word. To share this passion with as many people as possible, and because it genuinely makes me happy that these videos can help someone. Thank you so much, and see you next time.